This is Professor Darif Seitz, Trigonometry Inverse Functions. This section shows the graphs of the inverse trigonometric functions. In this diagram here, this graph, we see a section in blue of the cosine function. If we took the whole cosine, it's periodic, and it would not pass the horizontal line test, which means you could draw horizontal lines that intersected it in more than one place. When you can do such a thing, then the function does not have an inverse. It's very important to be able to have an inverse if possible, and the way to get it is to restrict the domain of the cosine and only work with the restricted cosine here. This little piece here of the cosine, every horizontal line only intersects it in one place. If we extended it any further, it would fail the horizontal line test. So using this restricted domain for cosine, and the restriction here is it goes from 0 to pi in the domain, and the range is the same as before, -1 to 1, then it will have an inverse. And if you remember about inverses, a couple of things. Their graphs will be reflections across the line y equals x, mirror images, because every point over here, xy, the coordinates will swap position, and yx will be on the other graph on the other side. And that's very key, because inverse functions undo each other. One maps one way and the other one maps back the other way. So the inverse of cosine, also represented by arc cosine, or it also a common notation is to have a -1 superscript to indicate an inverse function. Do not confuse this with an exponent. This does not mean cosine to the -1 power. In the context of a function, a superscript -1 means the inverse of the function. And as you know, inverses, the domain becomes the range, and the range becomes the domain. So here's the picture for the inverse cosine function in green here. Moving on to sine. Here's a portion of the sine graph from -pi/2 to pi/2. It's a restricted domain. Range is -1 to 1. And the arc sine, the sine inverse, switches those two, and here it is in green, the reflection across that line. The last one we'll look at graphically is the tangent. I can get this scrolled into position there. So in blue is the normal tangent. We restrict its domain to -pi/2 to pi/2, so we just have one branch of it. Its range is all real numbers, and so its inverse has a domain of all real numbers. It's defined everywhere in a range from -pi/2 to pi/2. What are the relationships here that we need to understand? Fundamentally, trig functions, the regular ones, map angles, fundamentally of right triangles, angles of right triangles, to ratios of right triangle sides. That's what they do. at a fundamental level. Remember, larger angles, you take the reference angle, which is acute. And trig inverse functions go the other way. They map ratios of right triangle sides to angles of right triangles. This is a key point. If you want to find an unknown angle and you know the ratio of sides, you can use a trig inverse function to find the angle. That's the key point here. Being inverses, they undo each other. If you compose the trig inverse at the trig, taking them in the order of first applying the trig and then the trig inverse, they undo each other. You end up where you started, x. So it's like x goes to y and y comes back to x. And alternatively, in the other order, trig at trig inverse is also undo each other. However, this is provided that all the expressions that you're using are valid in terms of the domains and ranges. Remember, we're dealing here with restricted domains, which means the ranges of the inverse functions are restricted as well. Everything has to be legal in terms of those restrictions. Otherwise, if one of the restrictions is not met, expressions must be evaluated individually from the inside out. Down here, if y is the trig of x, that's equivalent to x is the trig inverse of y. And if y is the trig inverse of x, that's equivalent to x is the trig of y. And don't forget these restrictions. So these are important functions. They're on calculators. So they allow you to solve practical problems that you couldn't solve before to find angles.